The first unit of study focuses on solving equations. An important mathematical skill associated with solving equations involves the process of simplifying. In this lesson, we will look at how to simplify algebraic expressions using the distributive property. We will take a look at questions involving taking a monomial and multiplying it with a binomial or polynomial. And we will also look at binomial multiplication using the FOIL method. Before we begin, let's review the difference between an algebraic expression versus an algebraic equation. So an algebraic expression is one that does not have an equal sign. So because it is not actually equal to anything, the most that we can do with an algebraic expression is simplify it and not actually solve it. So the example that we have here is 2x minus 6. So because this 2x minus 6 is not equal to anything, we can't collect any like terms and try to solve for what x is actually equal to. On the other hand, an algebraic equation does have an equal sign, and because of this, we can take the equation, we can try to simplify it as much as possible, and then go ahead and actually solve for the given variable. So now we have something that looks like this: 4 equals 2x minus 6. So we have the same expression from before, 2x minus 6, but now it's being equated to 4. So knowing this, we could take this, collect like terms, and isolate for the variable x and actually figure out what x is equal to. So I've gone ahead and collected like terms. So I took this -6 and brought it over to the right-hand side. Bringing a term over the equal sign causes the sign to become the opposite. So this -6 becomes a +6. So now that I've collected like terms, I'm going to go ahead and simplify. So I know that 4 plus 6 is 10. And now that I've simplified my equation as much as possible, I can go ahead and isolate for x. So in order to do that, I'm going to need to divide both sides by 2. And so 10 divided by 2 tells me that x has to be equal to 5. So again, to recap, simplifying just means that you are making the math sentence shorter or simpler by collecting like terms, whereas solving an equation, or if you see the term solve, that involves finding the actual value of a given variable. So what if we wanted to simplify expressions that were a little bit more complex? So remember from grade 9 mathematics, you learned the distributive property, and we can use the distributive property to multiply a monomial, so one term, with another larger expression. And that expression could be a binomial, so something that has two terms, or it could be a polynomial, something that has multiple terms. So in this example here, we have 3 multiplied by 2x minus 4. And in order to simplify this, we need to take this monomial 3 and multiply it into each term that is inside the bracket. If we perform that multiplication, we would be left with 3 times 2x, which is 6x, and 3 times -4, which is -12. Now, this is as far as we can simplify this because there are no like terms between 6x and 12 that can actually be put together. So this would be the final simplified algebraic expression. So let's try our first practice question. We have 2 multiplied by x minus 3 minus 4x plus 1 plus 1. So the first thing we want to check for, are there any distributions that could take place? So when I look at this, I see that I have a 2 attached to our first binomial, x minus 3. So 2 is going to get multiplied into the first bracket. Now, with the second bracket, the 4x plus 1, there is a minus sign in front of it. Now, there is no monomial or no actual value shown in front of the 4x plus 1. But in mathematics, we know that if we don't explicitly see a number, we can still put in a value of 1. So I put in a 1 in front of that bracket. So that actually means that we are going to distribute -1 into the second bracket. So we have -1 being multiplied into 4x and into 1. Okay, so now we can start to actually simplify. So let's go ahead and multiply our first set. So we've got 2 multiplied by x, which is 2x. And then we have 2 multiplied by -3, which is -6. We then move on to our second set. We have -1 multiplied by 4x, which is -4x. And then we have -1 multiplied by +1, which is -1. And then we have this +1, tagged at the end of our equation, and we're just going to recopy that because that wasn't actually part of the distribution. So now we have a simplified expression, but we can try to simplify this a little bit more by looking for any like terms and then collecting those like terms. So I see that I have a 2x and a 4x. Those are like terms. So if I put them together, it's actually going to be 2x minus 4x, which is going to give me -2x. And then I have some plain numbers that I can put together. So I have -6, take away 1, plus 1. So -6 take away 1 is -7. -7 plus 1 is -6. So our final simplified expression would be -2x minus 6. Okay, here's our second example. We've got 2x multiplied by 3x minus 1 minus x multiplied by 4x squared plus 2x. So pretty much the same idea as the previous example, but now we have some actual exponents attached to some of our variables. So same idea applies. We're going to take our first term and multiply it into its bracket. And then we're going to take the next term and multiply into its bracket. Okay, so if we go ahead and start, we've got 2x multiplied by 3x. Well, I know that 2 multiplied by 3 is 6, and x multiplied by x is going to give me x squared. And in case you've forgotten, when you multiply variables, you need to follow the exponent laws. So the rule for multiplication, or the exponent law for multiplication, is that when you multiply variables, you need to add their exponents. So if you have an x and an x, and you want to multiply them together, remember that each of these x's has an exponent value of 1. So if you were to add the exponents, well, 1 plus 1 is 2, and that is how we come up with x squared. If we continue our multiplication, we then move on to 2x multiplied by -1, which is going to give us -2x. We then can move on to the second set. So we've got -x or -1x. Remember, there is a 1 in front. So -1x multiplied by 4x squared. Well, if we focus just on the numbers first, we know that -1 times 4 is -4. And then again, following the exponent laws for multiplying, x multiplied by x squared is going to be x cubed. And then we have -x multiplied by +2x. So again, -1 multiplied by 2 is going to be -2. And x multiplied by x is going to be x squared. So once you've simplified, you want to check for like terms. And we do have like terms. We've got a 6x squared and a 2x squared. So 6x squared minus 2x squared is going to give us 4x squared. And then there are no other like terms. We've got a -2x, and there's nothing to go along with that. And we have a -4x cubed. And there's nothing really to go along with that. So this is as simplified as we can get it. And now if we want to rewrite our final answer in the correct order, we always want to list our terms by degree, so from highest to lowest. So you want to list them from the highest exponent value to the lowest exponent value. So that means if I look at my exponents, 3 would be the highest, followed by 2, followed by 1. So if I were to rewrite this, I could actually write this as negative 4x cubed plus 4x squared minus 2x. Now, both answers are correct. Okay, just in math, the tendency or the correct notion is to express your final answer by ranking your exponents in order. All right, what if we wanted to make it a little bit more complex? So we looked at how to multiply monomials by expressions, but let's try looking at extending this idea of distributing to a binomial. So taking a binomial, so something with 2 terms, and multiplying it by another binomial, so another set of 2 terms. In order to do this, we have to use a bit of a more fancier version of distributive property, which we like to call the FOIL method. So the FOIL method is, the word FOIL actually is an acronym. It represents first, outer, inner, and last. So it's basically just telling us the order in which to multiply the terms. So if we look at an example here, we've got one binomial, a plus b, being multiplied by a second binomial, c plus d. So if we follow the FOIL method, it's going to tell us the order in which to multiply the variables. So F stands for first, so that means take the first term in the first bracket and multiply it by the first term in the second bracket. So that would mean A multiplied by C. A multiplied by C is AC. And then we have the letter O, which stands for outer. So that means take the terms on the outer ends of your brackets. So that would be the A in the first bracket and the D in the second bracket. So A multiplied by D is AD. And then we have I, which stands for inner. So you're going to take the innermost terms of your brackets. So that would be B multiplied by C, which is BC. And then L stands for last. So take the last terms in each bracket and multiply them together. So B multiplied by D is BD. And then again, to simplify, you're just going to check, do you actually have any like terms, and see if you can put them together. So let's try an example. We've got x plus 4 being multiplied by x plus 2. So we're going to follow our FOIL acronym. So we'll start with multiplying the first term in the first bracket with the first term in the second bracket. So that's going to give us x times x, and x times x is x squared. And then we move on to O, which means outer. So we're going to take the outside term from the first bracket and we're going to multiply it by the outside term in the second bracket. So x multiplied by 2 is a positive 2x. And then we're going to do I. I stands for inner. We're going to take the innermost terms and multiply those together. So 4 multiplied by x is a positive 4x. And then finally we have L, which stands for last. So we take the last term in the first bracket and we multiply it by the last term in the second bracket. So 4 multiplied by 2 is a positive 8. So I color coded it for you so you can kind of follow along with the multiplication. So once we've done the multiplying, we're going to look for collecting like terms. So we have 2 like terms. We've got a 2x and a 4x. So those 2 can be put together. So we don't have anything that's going to go with the x squared. So I'm going to recopy that. And then I have my like terms. 2x plus 4x is 6x, or positive 6x. And then we've got the 8 on the end. So our final answer is going to be x squared plus 6x plus 8. All right, now it's your turn to try a question. So go ahead, pause the video, perform the binomial multiplication for this example, 2x plus 3 multiplied by x minus 2. Once you're done, you can come back and check your answer. So if you use the FOIL method, your first line should read as 2x squared minus 4x plus 3x minus 6. So that's 2x multiplied by x, which is the 2x squared, followed by 2x multiplied by negative 2, which is negative 4x. And then we have 3 multiplied by x, which is a positive 3x. And then we have 3 multiplied by negative 2, which is a negative 6. Again, you now need to check for any like terms. And again, we've got a set of like terms in the middle, the negative 4x and a positive 3x. So if we do our collecting of like terms, our final answer is going to be 2x squared minus x, or minus 1x, minus 6. What if we had a question written like this, 3x minus 5 squared? So it looks kind of complicated because you might think that you need to start distributing or applying the exponent of 2 everywhere, but take the 2 to mean that you're going to take the bracket and write it out twice. So we actually can rewrite this as 3x minus 5 multiplied by another 3x minus 5. And now we have a normal looking binomial multiplication that we can use the FOIL method on. So I'm going to go ahead and expand this by using the FOIL method. So I am going to be left with 9x squared. Okay, so that is 3x multiplied by 3x, which is the 9x squared. And then I have 3x multiplied by negative 5, which is a negative 15x. And then I have negative 5 multiplied by 3x, which is another negative 15x. And finally, negative 5 multiplied by negative 5, which is a positive 25. If we check for like terms, we have like terms in the middle. So I'm going to put those together, and that's going to give me a final answer of 9x squared minus 30x plus 25. So remember that if you see a bracket with an exponent 2 or being raised to an exponent of 2, the 2 just implies that you're going to take the bracket and write it out twice and then perform the FOIL method. Okay, our last few examples are still using the FOIL method, but we're going to increase the complexity of each question. So with question D, we've got negative 0.5 multiplied by x plus 4 multiplied by x minus 2. So it may look a little complicated because now, in addition to having your 2 sets of brackets, you've got another number in the front of the whole thing. So you actually have a couple of options here. You could choose to ignore the 0.5 at the front and just focus on the 2 sets of brackets and perform the FOIL method to expand and multiply those brackets. Or what you could choose to do instead is you could take the negative 0.5 and distribute that first into its bracket that it's directly attached to. And then once you've simplified that, then you could go ahead and perform the FOIL method. Doesn't matter which method you choose, you are going to get the exact same answer. So really it just comes down to personal preference. So what I'm going to do is I'm going to actually take this negative 0.5 and I'm going to distribute it first into its bracket, and then I will take what's left over and I will perform the FOIL method with that. So I'm going to begin by multiplying or distributing. So I've got a negative 0.5 multiplied by x, which is going to give me negative 0.5x. And then I have negative 0.5 multiplied by 4, which is going to give me negative 2. So that answer I'm going to keep inside a bracket because we still have that whole expression or that whole binomial attached to x minus 2. And now I can take these 2 sets of brackets or these 2 binomials and perform the FOIL method in order to expand and simplify. So I'm going to go ahead and start with negative 0.5x multiplied by x. Again, you could read this as 1x. So negative 0.5x multiplied by an x is going to give me negative 0.5x squared. And then I have a negative 0.5x multiplied by negative 2. and that's going to leave me with a positive 1x. And then I have negative 2 multiplied by x, which is a negative 2x. And then I have negative 2 multiplied by negative 2, which is a positive 4. And then our final step is to collect any like terms. So I'm going to recopy negative 0.5x squared. I do have some like terms. I have an x and a 2x. So 1x minus 2x is a negative 1x. And then I still have a plus 4. So my final answer is negative 0.5x squared minus x plus 4. So here's our next example. We've got 2 multiplied by x minus 3 squared plus 1. So remember, when you see a bracket raised to an exponent, in this case an exponent of 2, the 2 means that we need to take this bracket and write it out 2 times. So if I were to do that, I would have the 2, I'd have x minus 3, and then I'm going to write out another x minus 3, and then I still have plus 1 at the end. So again, it's going to be your choice on how you choose to proceed. You could take this 2 and distribute it into the first bracket, like we did in the previous example, or you might choose to FOIL the 2 sets of brackets together first, and then go about distributing and collecting like terms. So I'm going to use the same method where I'm going to take the 2 and distribute it first into its bracket, and then I will go ahead and FOIL. If you'd like to pause the video and try it on your own, you can, and then come back to see the full solution. So if I go ahead and distribute, I'm going to be left with 2x minus 6 multiplied by x minus 3 plus 1. And now I can go ahead and FOIL my 2 sets of brackets. If you perform the FOIL, then you would be left with 2x squared minus 6x minus 6x plus 18. And then you still have the plus 1 at the end, which you are going to recopy. Your final step then would be to collect like terms. And so your final answer would be 2x squared minus 12x plus 18 plus 1, and your plus 18 and plus 1 are actually like terms. So 18 plus 1 is 19. So this question actually had 2 sets of like terms. We had the x's in the middle, like we normally see, but we also had 2 plain numbers that could be put together. Here is our final example. This one is a little bit more complicated than what we've been practicing. We have a binomial, 2x minus 1, now being multiplied by a trinomial. So this actually has 3 terms, and in all of our previous examples, we've only been looking at 2 terms at a time. So we could still totally do this. It's going to still use a version of the FOIL method. We just have to make sure that we hit every single term. So the easiest way to do this is kind of just to work with 1 term at a time. So by that I mean, let's start with the 2x, and we're going to multiply it by the first term. Then we'll hit the second term, and then we'll hit the third term. And then we'll go to the minus 1, and we'll multiply it with the first term, the second term, and the third term. So we, in that case, get a multiplication with every single term and every single combination of terms. So if we start, we're going to start with 2x multiplied by x squared, and that is going to give us 2x cubed. Then we've got 2x multiplied by negative x, which is going to give us negative 2x squared. And then we've got 2x multiplied by positive 1, which is a positive 2x. Okay, now we're going to hit the second set. So we're going to start with negative 1, and we're going to multiply it by x squared, which is going to give us negative x squared, or negative 1x squared. And then we've got negative 1 multiplied by negative x, and that will give us a positive x. And then we've got negative 1 multiplied by positive 1, which is going to give us a negative 1. So now that we've distributed, our next step is to collect any like terms that we see. So I'm going to start with anything x cubed. So the only x cubed term I see is this 2x cubed. So I'm going to recopy that. And now I'm going to check for anything with an x squared. So we do have multiple terms with x squared. We've got this negative 2x squared and a negative x squared. So negative 2x squared minus x squared is going to be minus 3x squared. And then I'm going to check for terms that have an x. I've got a positive 2x and a positive x. So that is going to be a positive 3x. And I'm now looking for any plane numbers, and that's just going to be the -1. So that's going to go on the end. So our final answer is 2x cubed minus 3x squared plus 3x minus 1.